I've gotten quite a few questions regarding question 5 in the section 4.1, 4.2 homework. So I thought it might be time for me to create a quick video explaining how to do this particular problem. So in my problem, I have these numbers. And what do these numbers represent? A probability distribution of the claim sizes for auto insurance policy appears in the following table. This is a discrete probability distribution because the claims are numbers that can be counted. These are all counting numbers. And the probability adds up to 1. So if I add the probability column up, I get 1. And each of these probabilities are between the numbers 0 and 1. So it is a discrete probability distribution. And I know from the law of large numbers that probability and relative frequency are the same thing over the long run of an experiment. For example, if I flip a single coin, the probability of me getting a head is 1/2. If I conduct that experiment over and over and over again, let's say 50,000 times, then my relative frequency of heads would approach 25,000. So the probability of me getting a head would approach 1/2. So we can look at probability and relative frequency as the same thing. So this probability we can look at as a relative frequency. Since I can do that, I can let my calculator calculate the mean and standard deviation of this discrete probability distribution. And I do that by putting the claims, the numbers 1 through 7, in one list. I'm going to put those in L1, and I'm going to put the probability, which is a relative frequency, in another list. I'm going to put it in L2. And then I can let my calculator calculate the one variable statistics and give me the mean, which is also called the expected value, and the standard deviation of this probability distribution. So I'm going to do that. So I'm going to stop sharing my iPad, and I'm going to go share my screen. So here is my calculator, and I put in my calculator, in my stat menu, my data, my claims numbers, and then the probability of those claims taking on that particular value. All right, so let me go to my stat menu and edit. And in my first list, I put the numbers 1 through 7. And then in my second list, I put the probability that is associated to that particular value. Okay, so now I'm going to go calculate the one variable statistics for that data. So I'm going to go back into my stat menu. I'm going to go over to calculate, and I'm going to calculate the one variable statistics. And I'm going to calculate the one variable statistics based on my data being in my first list and my frequency, which again is my probability, in my second list. So I'm just going to calculate this. And I get that my mean is 4, X bar is 4, and my standard deviation is 2.024845, etc. So I'm just going to round that off to 2.03 or 02. That's close enough for what I'm going to do. So I'm going to have a mean of 4, which I'm writing down on my iPad, and a standard deviation of 2.02. All right, so I'm going to now go back to sharing my iPad. Takes me a second to do this. All right, so now back to my problem. I have a mean of 4 and a standard deviation of 2.02. And what they're asking me is, what percentage of claims are between one standard deviation of the mean? So I need to calculate that. I need to calculate what one standard deviation from the mean is. So one standard deviation below the mean, one standard deviation below, would be my mean minus my standard deviation. So I take my calculator out because I'm not sure I can do that in my head. I probably can, but just to be careful, we're going to do that on our calculator. And I get 1.98. And then one standard deviation above the mean, because that's what I'm looking for. So in between the mean, in between these two values, what proportion of my values do I get? I didn't say that very well. But okay, so one standard deviation above the mean is 4 plus 2.02, and that is going to be 6.02. So now I'm looking for what values are between 1.98 and 6.02. And this is a discrete probability distribution. So if I look at what this looks like on a number line, my values can take 1, 2, 3, 4, 5, 6, and 7. So I'm looking for the proportion that is between 1.98, which we can mark. Let's mark it in a different color. Let's mark it in blue. Right here, 1.98 and 6.02. So what values on my probability distribution are between 1.98 and 6.02? Well, that would be the numbers 2, 3, 4, 5, and 6. So what I do is I take those probabilities and I add them up. So the proportion, the relative frequency for my probability distribution occurring between plus or minus one standard deviation from my mean are the sum of the probabilities from 2 to 6. So I'm going to take my probabilities from 2 to 6, switch back to red. So probability of 2 is 0.15. The probability of 3 is 0.05. Probability of 4 is 0.3. The probability of 5 is 0.1. And the probability of 6 is 0.05. So I'm going to add those up, 0.2, 0.5, 0.6, 0.65. And then I'm going to change that to a percentage because they do want the answer as a percentage. So I multiply it by 100 and I get 65%. So I hope this little video helps you understand how this problem works. If you have any other questions, you know how to find me. Thank you very much.